to the afternoon session of our symposium. I'm going to introduce Patricia Franks, who will be the first speaker of the afternoon. Dr. Patricia Franks, Professor Emerita at San Jose State University, teaches courses in enterprise content management and digital preservation. She is a certified archivist, certified records manager, information governance professional, and certified information governance officer, as well as a member of ARMA International's Company of Fellows. Pat is a member of the CIGO Association Board of Directors, a member of Preservica's Digital Preservation Sustainability Council, and the immediate past president of the National Association of Government Archivists and Records Administrators, NAGARA. Her research interests lie in emerging technologies, including artificial intelligence and blockchain distributed ledger technology, and their impact on records management and information governance. I did hit that. That looks okay. Great.
Aloha. I'm so sorry I can't be with you today in beautiful Hawaii, but I'm delighted to have the chance to talk to you about one of my favorite topics, Paradata. My task today is to explain Paradata, what it is, and why we should care. A few years ago, Jenny Bunn, an InterPARES researcher from the National Archives of the UK, asked a question that demands an answer. If business is no longer to be transacted only by human beings, but also by AI agents or some combination of the two, what will evidence of those transactions look like? What will the record be? We believe at least a partial answer to this question is Paradata. But what is Paradata? For our purposes, Paradata is the information about the procedures and tools used to create and process information resources, along with information about the persons carrying out those procedures. The process encompasses all actions taken and decisions made from the initial plan of the AI tool through implementation and monitoring. The AI lifecycle shown is comprised of three main phases: design, which includes understanding the problem, gathering the data, and preparing the data for use within the model. Develop, which includes building and testing the model. And deploy, which includes moving into production and monitoring the output. XAI, or explainable AI, has received a lot of attention, rightly so. It explains why a given tool produced a given output from a given set of inputs. But building explainable AI requires more than an understanding of the algorithm. It must also consider the individuals and the environment in which the AI will operate. Paradata is necessary to explain why, how, and to what effect a given tool was used in a particular context. Some may wonder about the difference between metadata and paradata. Metadata is about the information resource. It is used to document, describe, preserve, or manage the resource. Paradata, on the other hand, is about the AI process. It is used to provide processual insight, transparency, and accountability. The archival perspective is one that supports the capture and preservation of paradata. The principles of sanctity of evidence, respect to fonts, provenance, and original order, the life cycle of records, the organic nature of records, and the relationship between records and their descriptions are all necessary to ensure that the AI process is captured in a way that preserves the characteristics of authoritative records: authenticity, reliability, integrity, and usability. Two statements made from the archival perspective are relevant to the discussion of evidence of the AI process. One, evidence explains not only what happens, but why, what worked and what didn't. Exactly what we need to do when developing any system, including an AI system. And two, the integrity of the material to be used as evidence is ensured if you can demonstrate an unbroken chain of custody. Provenance is one of the terms that is included in AI governance documents. Although we keep the records lifecycle in mind when developing records and information management program, The AI lifecycle must also be documented when developing and implementing an AI tool or technique. Understanding the AI lifecycle will help us identify the actions that must be documented. This is a machine learning lifecycle that breaks down the 3 phases we saw early on into more detail. As with all projects, you must start with a plan before you can determine what data is needed for your model. The data must be prepared and the model designed. Once the model is evaluated and meets the performance criteria set, it is deployed. The operation state involves implementation and management of the model. The results feed back into a continuous loop. However, the plan may not be to adjust the AI or continue as is, but to decommission it. If we consider the blue and green sections of the model, we can see the documentation needed can be placed into 2 broad categories. What we are calling technical in the blue and organizational in the green. Examples of technical paradata include the model, logs generated, training data sets, and vendor documentation if using your commercial product. Organizational paradata includes the AI policy, employee training, impact assessments, and regulatory requirements. There are many reasons to document the AI process. But simply put, we should care because AI is here and it must be governed. We'll examine 4 documents that provide guidance. The EU AI Act has been several years in the making. This year, the EU countries agreed to a final version of the Act. The full European Parliament plenary vote is expected either April 10th or 11th of this year. The EU Act provides a risk-based approach to AI governance. Risks are divided into 4 categories, with the first, unacceptable, being one that organizations would not have to document, merely avoid. Unacceptable or banned risks are those that threaten fundamental rights, such as biometric categorization systems that use sensitive characteristics, emotion recognition in the workplace and educational institutions, and untargeted scraping of facial images from the internet or CCTV footage to create facial recognition databases. High risks are those that pose significant potential harm to health, safety, fundamental rights, environment, democracy, and the rule of law. Examples include certain critical infrastructures like water, gas, electricity, medical devices, certain systems used in the fields of law enforcement, border control, administration of justice, and democratic processes. Limited risk include chatbots and certain emotion recognition and biometric categorization systems, as well as those that generate deepfakes. Minimal or no risk AI include recommender systems and spam filters, even games. Besides the documentation of the AI tool itself for the particular use case, including data sets, AI models, and so forth, documentation needs will vary based on risk level. High risk presents strict compliance obligations such as conformity assessments, in this case against the EU Act, and fundamental rights assessments. Limited risk AI tools present transparency obligations, such as informing users they are interacting with an AI system and assuring that it is apparent when a user is interacting with audio, video, text, and image containing AI-generated or manipulated content. There are no requirements for minimal or no-risk AI solutions, such as those games and spam filters. However, voluntary codes of conduct are encouraged. Another guidance document is the U.S. NIST AI Risk Management Framework. This encourages voluntary compliance with the document and 72 actions recommended in the accompanying playbook. Successful risk management depends upon a sense of collective responsibility among AI actors. It requires input reflecting diverse perspectives, disciplines, professions, and experiences. This guidance document is divided into 4 major areas of activity: govern, map, measure, and manage. Examples of the type of documentation recommended are shown on this slide. Within the govern area, we look to AI policies and employee training programs. The map function involves risk profile and tolerance levels, as well as data sheets for data sets. The measure function requires usability testing and stakeholder engagement plans. And the manage function requires privacy impact assessments, model cards, fact sheets. In Canada, Bill C-27 provides proposed amendments to the Artificial Intelligence and Data Act, or ADA. The ADA offers a balanced approach to regulated AI that will support responsible innovation and ensure international market access for larger Canadian businesses, while also considering the needs of small and medium-sized businesses. The bill extends the application of ADA to include obligations related to machine learning models, in addition to AI systems. The definitions for AI and machine learning models shown on the screen is what is included within this bill. The examples of high-impact AI systems in the Canadian document include employment-related decisions, biometric information processing, healthcare and emergency services, and law enforcement. The proposed ADA mandates 6 risk reduction acts. 5 apply to those employing high-risk AI in any jurisdiction. Data anonymization, assessment of high-impact status, risk assessment and risk mitigation plans, ongoing monitoring and risk mitigation measures, plain language description of systems and risk reduction measures taken. The 6th is specific to Canada. Notification to the Minister of Innovation, Science and Industry in cases of demonstrated or likely harms emerging from system use. This example is the Model Artificial Intelligence Framework Singapore, 2nd edition. It's supported by a companion document, implementation, and self-assessment guide for organizations. It is based on 2 principles: the need for explainable, transparent, and fair AI decision-making processes, and human-centric approach to AI solutions that protects human interests and amplifies human capabilities. In January of 2024, Singapore released a model AI governance framework for generative AI. The 4 areas of the model AI governance framework are internal governance structures and measures, level of human involvement, operations management, and stakeholder interaction and communication. Operations management, which includes data preparation, algorithms, and the AI model, is the area that most suggests the need for Paradata. The documentation recommended in the Singapore AI framework is explicit, for example, calling for data provenance records and audit trails, as well as implicit, suggesting the use of black box recorder, perhaps in autonomous vehicles. Algorithm audits may be required at the request of a regulator or a technology provider on behalf of his customer. AI Verify is Singapore's first step to identifying and defining an objective and verifiable way to validate the performance of AI systems. Several of the following slides are taken from content within a new article by 2 iTrust AI researchers. They posit dynamic environments in which AI must make decisions and take actions in real time, present additional challenges to capturing and preserving evidence to explain what happened and why. In their article, 3 types of environments are described. One in which there is a simple feedback loop involving sensors measuring the real world, control processes that determine the response to the real world stimuli, and actuators that execute or affect the response to the real world. The consequences of the system actions are then measured by the system sensors, and the cycle continues. In both the recommendation and action systems, humans are involved. The first model illustrates an AI system composed of an agent and its environment. The agent can perceive its environment through sensors and act upon its environment through actuators. An example is the autonomous robot, like the Roomba vacuum cleaner, that can operate autonomously in the physical world. Recommendation systems are different. A recommendation system is an algorithm usually associated with machine learning that uses big data to suggest or recommend additional products to customers. These can be based on various criteria, including past purchases, search history, demographic information, and more. Both the human and the AI agent receive input from the environment. The agent receives input to determine what recommendations to make. The human's response is fed into the system, for example, purchase or not, and used as input for further recommendations on behalf of the system. Action systems involve both the human and the AI agent making independent decisions and taking independent actions. For example, in the case of Vancouver's airport digital twin system, the system integrates sensors, historical, and real-time data into the platform to enable data-driven decision-making and collaboration. By modeling and predicting the behavior of crowds within the airport, the digital twin increases the throughput of travelers at bottlenecks, such as security checkpoints. In this example, the system's controller may be implemented directly through actuators such as changing the electronic signage displays. Changes may also be implemented indirectly through human agents, physically moving cordons and directing travelers. For all these systems, we can think about general paradata for the system itself and then for the organization. Examples of system paradata include code, model, algorithms, training data, test data, and more. Examples of governance and compliance information are audit results, impact assessments, and employee training. One example of a dynamic AI system is autonomous vehicles. The system's input and control processes form relevant paradata. Operational paradata related to the system includes sensor input, controlling processing, actuator actions, and resulting effects on the environment. In the case of AI-assisted surgery, augmented reality assists the surgeon to make decisions. Again, sensor input, controller processing, and actuator actions along with the effects can be documented, but will be different because of the use case. In this example, evidence might be in camera footage and paradata from intermediary processes leading up to a decision. The effects include consequences of the surgeon's actions, which would demand further treatment and follow-up, which would, of course, also be documented. Social media content targeting is a moneymaker for social media vendors. Facebook is no exception. The goal is to engage and influence visitors and sell products. System paradata includes a log of advertisements to show users and their interaction with those ads. Engagement changes the user's profile. Did they follow an ad? Did the following of the ad result in a purchase? The effects in the real world must be documented. A digital twin is an up-to-date representation of a real physical asset in operation. I've already mentioned Vancouver's digital twin at the airport. Creating a digital twin enables you to generate sensor data for a predictive maintenance workflow, helping determine the optimal time for maintenance and reducing downtime while preventing equipment failure. That's just one use. The Chattanooga Digital Twin Project led to reduced emissions and shorter commutes for citizens in metropolitan Tennessee. Researchers used machine learning and real-time data collected from a wide range of infrastructure sensors to create a digital twin depicting Chattanooga traffic conditions. Via sensors installed on roads, this dynamic data-formed simulation captured real-time traffic conditions, providing researchers with a portal to understand some of the underlying causes of existing traffic congestion. These insights generated from the digital twin allowed researchers to pinpoint specific areas for improvement, test possible solutions, and recommend effective traffic management strategies for city officials. A digital twin system, such as the one implemented at Vancouver's airport, results in similar documentary needs: real-time data, logs of decisions produced by the system, orders and notifications to humans, and actions taken by the system, as well as the effects of the decisions and the actions on the real world. When you consider employing AI within your organization, I hope you'll keep some of these thoughts in mind. Decisions made and actions taken by AI-enabled systems must be documented. Some of the documentation will be automatic as part of the AI system. Some will be human-created prior to or after the creation and implementation of the system. Paradata is recommended to document the AI process and promote transparency and accountability. The archival perspective supports the capture and preservation of Paradata and is necessary to ensure the AI process is captured in a way that preserves the characteristics of authoritative records: authenticity, reliability, integrity, and usability. Guidance in the form of laws, regulations, and frameworks must be monitored. Furthermore, a risk-based approach is recommended for AI governance. High-impact, high-risk AI implementations demand the most attention. Dynamic systems that rely on real-time data to make decisions and perform actions may involve both the AI agent and a human agent. The capture of Paradata in these environments is complex. Standards are emerging. Be sure to keep abreast of new releases. A full-fledged information and AI governance structure is necessary. Risk, value, cost, trade-offs must be considered. And every organization should begin to discuss the topic of AI governance now. Thank you very much, and enjoy the rest of your time in Hawaii.
Thank you, Pat. Let's see. Is Moatez in? Yes, there he is. Okay. Our next speaker is Dr. Moatez Nagoudi, who is a postdoctoral fellow in the Deep Learning and NLP group at the University of British Columbia. His current research focuses on the development of large-scale language models for natural language understanding and generation, neural detection of misinformation and machine-generated text, and multilingual machine translation. He completed a dual PhD in computer science from ATL University, Algeria, in collaboration with Grenoble Informatics Laboratory in France. Before coming to UBC, he held multiple positions, including assistant professor at the CHL University, Algeria, and a member of the Computer Science and Mathematics Laboratory, also in Algeria. Welcome, Moatez. Adam, it's not showing up here. Is it on the desktop? Oh, there it is. Oh, yeah. Well, I think it's from the drive.
That's fine.
Well,
Hello, everyone. I am Moatez, as Corinne said. Thank you, Corinne. So today I'm going to talk about our ongoing work entitled Archive GPT Mode. So this work was done by myself and Alcides and my supervisor, Professor Mohammed Abdel Majid. So here is the agenda of this presentation. I'm going to start with an introduction about large language models. Then I will talk about the hallucination problem. Then I will try to talk about the solution proposed for this problem. In particular, I'm going to talk about the retrieval augmented generation. And I will finally talk about the application on the archive domain. So as you all know, the LLMs are machine learning models that are trained on very huge data, and we train them to generate text based on the prompt provided by the user. So this model are trained from billions of tokens, so it's really hard to know which part of these models are remembered and which part does not. So in fact, when generating text, the model cannot guarantee the accuracy of these generations. So actually, large language models are facing now very serious problem, which is the hallucination problem. So what's the hallucination? Hallucination, so it's the problem that refer to when the model try to generate text, which is like these texts are incorrect or incoherent or not real. And as you all know as well that like these LLMs are not databases or search engines, so they cannot provide the sources of their information. This can lead that we are not very, very like 100% that the information provided by these LLMs are correct or not. So for example, if we take this example of a non-existing New York Times article based, and we ask ChatGPT to generate like a summary of this article, which is like fake because we give him like fake URL. So right away, ChatGPT tried to generate a random text based only on few words that appear in the prompt, which is totally wrong. So this can be like cause very, very serious problem if we move to like sensitive domain, like medical domain. So for example, if you are thinking to ask ChatGPT for like some medical advice, think again, because like really, really, really new research from Harvard Medical School show that like 33%, around 33% of like the advice provided by ChatGPT are wrong. So which is like can cause very, very serious problem if we use this framework on applications that make medical decisions. So why actually LLMs hallucinate? So because like they are static, they are not up to date. So also they lack domain-specific knowledge. For example, GPT-4, they don't know about your company's private data, and they also behave like as black boxes. So we really don't know how these LLMs are able to provide this answer and not another answer. So we have different types of hallucination. For example, hallucination can happen in like different or diverse forms. We can find like sentence contradiction, prompt factual contradictions as well. We have like sometimes we have like non-logical responses, and several times some random LLM hallucinations. So for example, if we take the example of sentence contradiction, this occurs when, for example, a language model generates a statement that is directly, one statement which is like directly contradict with another statement in the same response. For example, if we have like a statement in the first sentence in the article, a human body has like over 500 bones, and in the middle of the response we can find like MRI shows that John is a very healthy guy, and his body has like 206 bones, which is like contradict with like first one. Another hallucination type, which is prompt contradiction. So we can find, for example, if we ask the model to give us 5 reasons why the water is important, and somehow we have a response that humans don't need water to survive, which is like contradict with the, which is actually not aligned with the actual prompt. Another actually serious problem, serious hallucination type, which is like factual contradiction. Sometimes if you ask, for example, the ChatGPT, who is this player, I'm gonna ask you, for example, he's gonna tell you like Lionel Messi is a Brazilian soccer player, which is wrong. And also we have sometimes no logical responses. For example, if you ask him why 2 plus 2, or what 2 plus 2, and he's gonna give you like some random response like apples are great for building houses or something. Yes, and also we have also random LLM hallucinations. So for example, if you ask the model as well, give me like a story about books in like in the library, and he told you like this morning my book decided to go to swim because like it was too hot in the library. Yeah. So actually we have a serious problem, and we really need a solution for this problem. So for this reason, people they like give us like a very nice solution, which is like retrieval augmented generation, or like RAG for short. So what is a RAG? Actually, a RAG is a system that can provide some information to the LLM. This information or this contextual information can help LLMs to give us like some accurate or more performant answers. So let's try to really understand how like this RAG works. Like let's try an LLM with and without RAG. So here is like an image to show a simple work frame for like how like this let's say, framework LLMs works. For example, we have a user, and we have like framework, which is in this case GPT API or Gemini API or whatever, and we have the main model. So if a user asks a question, the question don't go directly to the LLM. We have a framework. This framework put this question under a specific format, and then give this like this format to the LLM. LLM provide us an answer. This answer taken by framework again, do some post-processing, and we have the response to the user. So to really understand this like process, let's ask this question to ChatGPT 4.06.13 version. So if we ask this model for which club does like Lionel Messi works, and we have the prompt, it's not gonna be like this, like right away, like this. We have two parts in this prompt. We have the system part and the user part. The system part, we just ask the model to give us like some answer for some answer. Yes, we tell him that answer the following question the best you can. And the user part, which is the real question, which is like for which club does Lionel Messi play. So LLMs try, in this case, the response of the LLM is like not like correct, which is like, he tell us like, or as my last update is 2021, Lionel Messi is like a player for Paris Saint-Germain, which is like wrong. So let's try to see other RAG and see how it's like the model behaves. So the RAG architecture is similar as like previous one. We just like have a RAG component on the top of our architecture. So this RAG component is composed from two main components, which is like a sentence embedding model, and we really need like a lot of contextual data. So when a user asks a question now, the framework don't send the question directly to the LLM. The framework, like the question trigger a semantic search using this vector database, which is like sentence-based embedding, as I mentioned, match the query with like the most relevant document or context that match with the query, send this information to the framework, concatenate this information with the original question, give the whole context to the LLM. LLM try to respond to this question with more context now, and send the answer to the user. So if we take the same example as the previous one, but using the LLM, we have now GPT-4 using RAG. We have the same first part, which is answer the following question as the following question the best you can. And we have the output of the RAG, which is in this case, Lionel Messi has signed with Inter Miami CF Club until 2025, etc., etc. So, and we have the original question, which is for which club does Lionel Messi work? And in this case, the LLM has like more information. So even if he's not trained on this data, but he has like more information about this question, so he can give us the correct answer, which is Lionel Messi plays for Inter Miami CF Club. Yeah, so the question now, how we can use this technique in our archive domain. So what we are working now, what we need actually, so we really need three components. We really need an open source LLM, very, very powerful word embedding model, and a large amount of archive data. So in this case, we use like Mistral 8 Expert 7 billion models. And we use as well a sentence-based sentence embedding model, which is like flag embedding, which is like state-of-the-art English embedding model. And for archive data, we can use as much we can for contextual data. So using this framework, and let's see the impact of this framework, or like the adding RAG on the top of Mistral in the archive domain. So let's have this demo. So we ask first like Mistral, our Mistral without RAG. So we tell the model write a very short summary about data sanitation techniques by Edgar Dale, and write the citation in API style. So the output of the Mistral output is like, for the definition, he gives us like some kind of close definition, or let's say general definition. But the problem in the citation part, the citation part in this case is 100% wrong. He put it really under the API style, but really there is no Dale 1962 data sanitation technique, Journal of Data Management and stuff. All this stuff is like wrong. Yes, it's just fake. Yeah. And the problem here, he put it in the right format, which is like, can like get the user very confused. So if we use a RAG on the top of our mixtural model, we really have a very nice output actually. So we have this document in our archive dataset. If we come back here, in this archive dataset, we have several archive data, which is one of them, this document. And this like question is related to this document. So now the definition is very nice definition and very fluent and match with the original document. And also the most important thing that the citation is 100% correct. It's under API style, and the model is able to give us like a correct citation and the definition as well. So yes, as I mentioned maybe before, this like work is like still ongoing. So we are like still working on scaling this this model, and maybe after like a few months we will have like maybe state-of-the-art model on archive data domain. Yeah, thank you.
I'm sure there are some questions for Moatez. Yes, Massimiliano. Oh, Fred. All right.
Oh, yeah.
Massimiliano, you need to come around to the microphone over here. Go ahead, Fred.
So it seems to me like you're using a standard database search to find the answer and using ChatGPT to make it sound right.
Actually, not find the answer, find the context of the answer.
So
That may include the answer.
it may include, yeah. So if you found multiple database entries, or suppose you found an entry for that example
Yeah.
of somebody got the job,
Yeah,
but after that there was more information, they got a different job,
yeah.
and you didn't find it in the database, then ChatGPT would still give you the wrong answer, but it would at least be based on some factual information. Is that right?
Yes. Actually, because this like RAGs don't solve 100% the problem of hallucination, so help to solve the problem of hallucination. Yeah. Thank you.
I would like to ask a question concerning the workload required by the arrangement of a RAG system. Okay, we have seen a powerful means of enhancing and checking the possible hallucinations on the, but how much work does it take to set up the framework? Is a work that is to be done manually or automatically, maybe assisted by artificial intelligence or by automatic means? Because then one of the things that we have realized in our group that there is also a problem that is a very, in a sense, mean problem is to be considered, factoring in how much work, human, financial, time, resource, intensive work is necessary to set up the system. This was my
Yeah, actually it's a very nice question, but I would say we have actually two components on this work. The first one, we did it yet in this work, which is like instruct, fine-tune the mixed-serial part on like archival data, which we are like trying to do. And the second part, like collect as much relevant archival data and like plug them in like our RAG component. And like by using these two components, we feel that we are able to get like very nice output. Yeah, thank you. We have only 2 questions. Go ahead, please, Adam.
I don't know whether your research really inspires me or just scares the living daylights out of me, or a little bit of both. Because the whole concept of hallucination is just so dangerous.
Yeah.
Because we're so used to you Google, you get a result, and you go right to where you need to. Now we're putting a lot of faith behind the scenes in a model that you all are developing that we never even approach.
Right.
So my question is given the very little experience I've been playing in this, my demo, for instance, with Microsoft, since it's on a very finite set of data, it points to the references. This is where I got the answers from. Do you see any movement in the larger body because of some of these high profile, lawyers being super lazy and just saying, write something for me, and it makes up legal cases? How the hell does it do that? To get some of that pushback to open up the result set somehow so that we can get better visibility to have greater faith in the results that we're getting back?
Actually, your question is very, very long, so I'm going to start to hallucinate as well. So,
Cite your sources. How's that? Is there any movement to citing where they're coming up with these answers?
As you know, like large language model is based on the context size. As I mentioned, like your question is very, very long. Maybe I'm gonna pass this question to Prof to discuss like. Yeah, no, yeah. That's it.
Okay.
Thank you.
And didn't Doug Murdoch say that every answer is a hallucination and sometimes it gets it right? Thank you, Moatez. Okay, next we have Proscovia Svard. Dr. Proscovia Svard is an associate professor at the Department of History at the Sorbonne University, Abu Dhabi. She's also a research fellow at the Department of Information Science, University of South Africa in Pretoria, and she carried out her postdoctoral research at the School of Interdisciplinary Research and Postgraduate Studies, University of South Africa. She has a licentiate degree in Data and Systems Science, BA and MA in Archives and Information Science from Mid-Sweden University in Sweden, and a BSc in Media and Information Science from Uppsala University in Sweden. Her research interests include enterprise content management, records management, information culture, e-government development, public sector information and open data, long-term preservation of digital information, Truth and Reconciliation Commissions and their documentation processes, the role of archives in enhancing accountability and transparency in government institutions, information access and the link to democracy and development, and new public management and its impacts on the management of government information. She's the author of a book entitled Enterprise Content Management, Records Management and Information Culture Amidst E-Government Development. Welcome, Proscovia. Just have to get that. Where's the, I don't even know where the thing is to turn it into. Right there, down there, that thing. Yes, that will turn it into. No.
We could do a slideshow of
Yes,
the answer.
this is the slideshow thing.
But is it on the first slide? It isn't.
There you go.
No.
I don't know why it started at the end.
I think this is where we
There
should.
you go.
Thank you so much, Corinne, for that introduction. I would like to start off by thanking InterPARES for the facilitation for my participation in this symposium, and Sorbonne University, Abu Dhabi, but also our wonderful host, whose name we know by now. Thank you so much. We've been carrying out a study that has focused on the domain of e-government development, and we are trying to understand how records management is impacted in areas where AI is being applied. And so we carried out a systematic review for our first study. So what I'm going to present to you today is the second phase of this study. So the first one, we try to understand whether records management is at all regulated in all the regulations that are coming out around AI, and of course it was very difficult to access any literature. The systematic literature review failed, and we had to do some scoping review in order to understand what's happening. And of course, that article has been submitted to the Records Management Journal. It's under review, but we are terribly worried that maybe the review is taking a long time, compared to what's playing out. As far as emerging technologies are concerned, this is such great speed, so we don't know what will happen when the results finally come out. But what I'm going to present to you today is focusing on what challenges there are amidst the deployment of automated decision-making, or AI, in the public sector. And we are focusing on 3 countries: Sweden, where I live. I work in the UAE, but I'm a citizen of Sweden. and Finland and South Africa. And so this is the team that I have with me. We have an AI person who has become an associate professor at the University of Umeå. He has just moved from Vasa. We have the two professors, associate professors from the University of South Africa, and Associate Professor Hentonen. I think many of you maybe know him from the Tampere University, and a postdoctoral research fellow who is working with us. So I will be presenting you an introduction to this very study, the aim of the study, what I see as a research problem, the methodology I followed, and research findings. I'm saying I because the first part of the study will be predominantly focusing on Sweden, since when it comes to Finland, I was only sent preliminary studies, and when it comes to South Africa, they had a requirement to have a clearance from the ethical committee, and so that study couldn't be fully implemented. Of course, many of you know the definitions of what I'm going to read to you now, but automated decision-making in the public sector has become motivated by the need to achieve accurate, fair, efficient, and uniform decisions through the exclusion of humans. That's how these researchers define it. So automated decision-making is defined by this other researcher that as an administrative decision-making being partly or fully based on automated outputs generated by algorithmic systems that incorporate relevant regulations of a given policy. And they may include robotic process automation, rule-based expert models, regression, big data, predictive analytics, machine learning, and neural networks, to name but a few. So AI is in this study based on the European definition of what it is. And this is a system that displays intelligent behavior by analyzing its environment and taking actions with some degree of autonomy to achieve a specific goal. And so the terms artificial intelligence, machine learning, and automated decision-making are used interchangeably. These two researchers argued that automation, of course, plays an important role in managing complexity, curbing uncertainty, and performing mass activities at an affordable cost. And so algorithmic automation is expected within the public sector, the way it's being deployed, to streamline processes, improve efficiency, reduce costs, and assist in decision-making. However, despite the many claimed advantages, there is also research that warns against certain risks. And this could be the perpetuation of choices and preferences, radicalization of speech, standardization of behavior based on stereotypes, polarization of public opinion, enlargement of bias and discrimination of opaque decisions, and lack of transparency and accountability. And that's where my focus is, lack of accountability or transparency. So these two researchers posited that though the public sector must harness technology to improve service delivery, it has to do so cautiously in order to avoid any harm that might happen to the citizens. And this is because although AI has the potential to transform, of course, societies and their economic systems, the risks it poses must be governed and the democratic values and human rights respected. So some of the reviewed authors argue that although some of the studies have doomed the power of the civil servants in decision-making, technological, organizational, political, and ethical issues will require different configurations where both the civil servants and algorithmic systems will need to share that decision-making authority. And so traditionally, transparency and accountability within public processes is attained through access to the official record. That's the only way citizens can follow up on what has been decided on. So with the emerging technologies, such as AI, the definition of a public record in these processes where AI has been deployed is becoming quite complex. So the documents that derive from such processes are not well defined or understood by all those involved. So the aim of this study was to investigate the management of public records, how the management of public records is affected in areas where automated decision-making and AI are being deployed in government institutions in Sweden, Finland, and South Africa. And the questions that we are trying to ask are, what are the areas within the e-government development realm what are the areas where automated decision-making is being deployed, and what are the records management challenges? Now, for the sake of definition, e-government, we all know that government institutions of most countries are engaged in the use of technology, and they're developing electronic services, upskilling the government officials, and of course, the intent behind e-government development is also to increase transparency and accountability. So, and that's why it's quite interesting to see what exactly is happening now with all these disruptive or emerging technologies. So we took a case study method, and in my case, from the Swedish perspective, I looked at 8 cases, and these included agencies and municipalities. And through interviews, I could access, what's going on within these research settings. And the officers interviewed included digitalization strategists, e-service developers, business process developers, and archivists. And so since the 1990s, the Swedish Parliament has encouraged this administration to harness technology to improve interactions with the citizens and companies, and to also develop electronic services. However, it also highlighted the need to adapt an administrative framework for decision-making. So Rachel, whose article came out last year, posited that although the legal consequences of digitalization, automatic decision-making, the general administrative law, the principle of transparency, and the right to access public records have been subject to several government-commissioned inquiries in recent decades in Sweden. There are still very few general rules on automated decision-making, and therefore there are several issues that are still unclear. So if I'm to share with you some of the research findings, there was, of course, this is so traditional, lack of the involvement of the sections managing public records and the information security issues. And one of the archivists, for example, expressed the challenge of continuously forging relationships. They usually have ambassadors that they send out to the departments to watch over what's happening and where the new developments are, where AI is being deployed. But of course, after some time, they leave. And so they have to, again, forge new relationships. But there are also difficulties in identifying and capturing the new forms of records that are emerging, and the difficulties to undertake appraisal or manage the records as evidence. Of course, you can't manage what you don't understand. So in one of the municipalities, the archivist was not sure what type of records that, for example, emanated from the use of this robot called Herbert that was being used in different processes, because she said she only dealt with the records that ended up in the business system. So I'm just going to read you this quote because it sort of explains what is happening in most of these agencies or municipalities. So the archive perspective that should be considered during the introduction of new IT support systems is missing. And this is due to gaps in knowledge about archives and the management of public documents. The archive function has not made itself sufficiently known in the organization. Informing about information management and archives in a large organization such as a municipality and developing the knowledge of the employees is really a challenge. The organization creates more information that those who work with information management know about. It's difficult to have an overview where the information or data is being generated and how it should be taken care of. It's further difficult to know whether this is information that should be appraised or disposed of, and that if that's the case, when should it be done? If something went wrong, would we be able to trace what went wrong? And yet we depend on it to understand what goes wrong, or worse still, do we even notice when things go wrong? And so in one of the cases, there was a case, a case that was to be introduced to the management. And this involved an AI generator, which is likened to a ChatGPT 4.0 that was being suggested, by the supplier. And so the company is using language models, machine learning models, and selling licenses to those interested in this support function. So the meaning is to use the language model as a base infrastructure upon which the municipalities can add manually their own data. So they were to start with steering documents, guidelines regarding archives, archival descriptions, and so on. And of course, they were to later on upgrade by putting in more documents, more data into the system. And the intent was to reduce the administrative burden. But of course, there were also issues identified, like, for example, the trustworthiness of the responses of the AI generator. And I think what has just been shared about the hallucinations is enough to make this, to draw attention to the fact that the officers themselves need to be trained in order to be critical and not to entirely trust the responses that the AI generator produces, because it's, again, people who upload the documents upon which the responses are based. So there was the language model. The language model, well, there was also need to secure the language model to avoid any data leakage. They also needed to ensure the right to own their own information. So the disadvantage of this development, of course, is that wrong answers might sort of be given to the prompts that are used by the officers. But there were also issues of provenance and authenticity of the documents uploaded. So somebody has to put up a robust system in order to know what documents are being uploaded in order to get the right responses. So the respondent who worked as an information strategist and had an advisory role confirmed that during discussions on AI and digitalization, very little attention is paid to the management of information, even though it's claimed this information that it drives processes these days. And so people are focusing more on AI technology than on the management of information. And these are some of, actually I got this through the literature review that I undertook, whereby 2 journalists had been declined to access public records. And now it turned out that one of it was the source code of a software that had led to the decision he got, and so he wanted to access the source code. Is this one type of document, public record, that should be provided to the information seekers? Because in this case, this was a Norwegian company that had delivered this service. But since it was involved in the setup of the algorithm that led to the decision, now the person who had been declined to have access to the source code had to appeal that decision. But there was also a conclusion of any information that could deliver meaning in how the decision was arrived at. So in conclusion, there are, of course, many areas where AI is being deployed, like you see on that list: schools, public administration, the Migration Agency, Health and Social Services, the Swedish Transport Agency, the Board of Student Finance, and the Social Insurance Agency. But there are new types of records that are growing out of this area. the archivists are not so, they haven't yet figured out what these records are. So the same traditional problem of exclusion of archivists or records management functions also persist. And there is a focus, of course, on technology and efficiency. The management of records has not been prioritized to maintain the two tenets of democracy, which is transparency and accountability. And when it comes to Finland, this is what was shared by my Finnish colleague. He says the Finnish legislation sets limits to the usage of AI in decision-making processes. There are also several criteria that must be fulfilled if AI is to be used in decision-making. So automated decision-making is only allowed if the case can be resolved without case-by-case consideration. And in addition, among other things, there must be documented rules that describe how a resolution is reached from the inputs and the named officials who bear responsibility for the decision are able to identify errors in the process. So the use of AI technology as a black box in decision-making is prohibited. So he quoted a number of areas where AI is being deployed. Of course, there were 16 in number, but I'm only going to share these ones in order to save time, like in the Prime Minister's office, where there is intensified processing of emails coming into the registry office through automation. We have the National Audiovisual Institute which has automated the cataloging of work processes, the Legal Register Center, the Center for Government Finance and Human Resources, the National Courts, and the National Police Board. But he also concluded that records and archives management concerns have not played a visible role in the named initiatives. And what is noteworthy is the need for risks assessment and accountability requirements through records management. And if I'm to go on to the South African case, my colleagues say that it is gradually being integrated in the public administration, but also the financial sector. And public administration, it was within the placement, regarding the placement of school children in one of the provinces. So there are research findings. There are also preliminary findings based on literature, since they have not been able to get any clearance to gather empirical data. But they, from the literature, could find out that there are challenges of the digital divide, concerns about data security and privacy, protection of personal data, lack of standardized data formats and interoperability, and concern regarding misuse of data. And so they concluded that there is no literature on the adoption of automated decision-making in the context of records management, but there is great potential in the use of automated decision-making in managing public records in South Africa, but careful consideration of regulatory frameworks are needed. And with that said, I thank you for listening.
Thank you, Proscovia. Are there any questions for Proscovia? Jessica, and then Tracy.
Please use the microphone.
Yes, the microphone is over here.
Yes, Jessica.
Thank you for that informative presentation. I'm curious about the second case study that you mentioned being done, I think, in Finland. Mm-hmm. You mentioned that they were using AI to automate processes with the audiovisual, television and radio archives. Is that correct?
Yeah, that's correct. And unfortunately, I don't think, you can try to ask, but I don't think I will deliver an answer.
Well, I'm just, yeah, I guess I was just curious if if your team has a contact there where we could find out a bit more information about how they're using it with those audiovisual materials, since it's a theme
Absolutely,
we're interested in.
absolutely. I can't give you Pekka's contact because he's the Finnish researcher and he's Finnish and works at the Finnish university, and so that will be easy to fix.
Great, because I just think in the context of what Adam spoke about earlier today and what Peter will be speaking about, it would be very interesting.
Yeah,
Thank
sure.
you.
Thank you so much.
Two related questions. One is, were you able to distinguish between automated processes and processes using artificial intelligence? And when you're speaking of some of the data, are you speaking also of administrative data, the data that are created by the state to administer services, such as the delivery of healthcare or number of people that are submitting their taxes through the automated tax system, et cetera?
The look we are taking within the study is, public records in general, regardless of the process, wherever there is an automated process. Like, for example, if we take the AI generator, the project that was soon to be implemented, there was no decision about it. But of course, if you were implementing AI, then you also need to understand, so what could be the possible records that can grow out of such a process in case things go wrong, right? This particular municipality was trying to create its own chat GPT, but they are using a language model which they have to pay a license for and add their own data on it. So now the issue is, for me as a person based in this domain, I'm interested in understanding, so what happens in this process, for example? This is a process that is generally going to help the burden of administration. Like, for example, if you have officers that are dealing with business processes but are not so informed about how to manage records, they have usually doubted, can I dare post this kind of record over the internet using email, or should I? So those kind of questions, instead of running to the archivist who might be busy, and since AI is here to facilitate lives, like we've all had, then they would sort of prompt it in order to give them an answer. But now this was a process where they had to actually upload, like, for example, the steering documents and other types of documents. So in case the human error happens, I mean, we could borrow the word of hallucinations, and the administrator gets a wrong response and then relays that response, or could actually be in the process of creating a record herself. But the response upon which she's going to build, to sort of base this response was a hallucination from the AI generator. What happens? Who is held responsible? What are the types of records that can sort of enable? It could be a citizen that ends up getting a wrong decision. What are the types of records that are growing in this environment? And how can we uphold transparency? How can we hold people accountable when such things happen? Because right now, I think the general feeling is that archivists have a tendency of not wanting to get so involved with emerging technologies. I'm sorry for the rest of the archivists, but my own experience, I usually do a lot of research in municipalities because those are very rich data, they are good at, giving empirical data. And so when such things happen, like they haven't been involved in open data, that's one area, but a lot of things have been happening there. And now with emerging technologies, again, they try. Some of them who are interested maybe try, but things are not so clear, things are not so clear to most of us, And this is a development where we need to get concerned. So what's happening? In case of any failures, what happens? Where are the records? What are the types of records? One journalist was asking for the code, for example. What type of record is that?
Thank you very much.
Thank you, Proscovia. Okay, next we're going to hear from Peter Sullivan. Peter is a doctoral student in the PhD program at the University of British Columbia. There's a theme here in terms of location. His research interests focus on speech processing, domain generalization, and applications of AI to audio archives. Peter has contributed to the delivery of tutorials and workshops on AI for records and provides support to several studies in the InterPARES Trust AI project overall. Peter.
Thank you, Corinne. Thank you, Adam, for being a wonderful host. And I'd also like to thank Ing Sangsatang, my co-lead on this study, who unfortunately is not able to be here today. So I'm here to talk about the UNESCO Radio Archives AI Audio Metadata Enrichment Project. And our driving question for this project is looking at how AI can enable better description of archival audio. So often you may have archives that have boxes of tapes locked away. No one may know what is in them. And so once they're digitized, you may similarly have a folder of files, audio recordings, that you still may not know what's there. And we want to tackle this problem head on to see if we can extract information about what's on the audio recordings to make them more easy to discover and to better use their value as historical records. So our project goals are to understand the relationship between the physical record and its digital surrogate. So not only the audio file that was created when it was digitized, but other things like transcripts that might be generated from AI through this process. We want to look at whether diplomatic analysis, of which you can talk to Luciana Durante, the foremost expert on, to learn more, but to use the structure of a record to better enable sort of the information extraction from that record. We also would like to analyze whether and how AI models improve performance during the metadata creation, control, and enrichment. And finally, as with all studies with AI, we'd like to analyze the risks, challenges, and potential biases of these models on real-world data. So to start off, I'd like to give an overview of the radio archives. So there are approximately 16,000 recordings that have been digitized, of which only 1,000 have been fully enriched. And at that rate of several years it's taken for those 1,000 recordings to be enriched, it would take about 40 years for the entire archives to be completely described. The archives encompasses all of the physical tapes that were created by the radio station from their operation period between the 1950s and the 80s, at which point they switched to a digital format for saving their files. There are 70 plus languages that are spoken on these recordings, including many of which are simply labeled as multilingual. So we don't even know what recording language it's in. And this is very challenging for things like automated speech recognition, which you might use to create a transcript. If you don't know what language it is, it's sort of a shot in the dark to see if you get it correct. Or even more challenging if there are multiple languages on that recording. UNESCO, as the UN Education, Science, Cultural Organization, has a broad coverage of topics, including education, cultural, natural science, communication and information, social and human sciences. In addition to these core aspects of UNESCO, there's also a part of the radio archives which is devoted to capturing the history of UNESCO, including meetings and different speeches by UNESCO VIPs at various functions. And so our genres include interviews with UNESCO members, speeches by VIPs, as well as educational programs for the general public. Our metadata enrichment plan is focusing on several key metadata pieces that can help build out the rest of the metadata fields. One being personalities, who is speaking on the recordings. The second being the language of the recording. And as I mentioned, if we know the language of the recording, it's easy to create a transcript, and from there we can build a description. So our plan is to use a set of existing AI tools and look at how they can meet the needs of archival institutions. Speaker identification and speaker processing related techniques to understand who is speaking on recordings, language identification techniques for the language, a combination of automatic speech recognition and machine translation to generate transcripts in a language that the archivist or archives intern might be able to use, and then potentially extractive summarization to pull out the key aspects of that transcript that might be relevant for creating a 2 to 3 sentence description that you then search for on an online portal. There we go. I'm going to go through the story so far for our case study. So we had an initial focus group to examine ASR transcripts as well as language identification predictions for a subset of the recordings. What we found is that the transcripts were actually quite reasonable if that language ID prediction was accurate. I'll talk about this more in just a second. We also performed, we have started performing diplomatic analyses of the transcripts, of which we hope we can find some structure to enable extractive summarization. And most recently, we've been looking at language identification and speaker processing techniques to better understand the limitations of using these tools on archival data. To talk more about our initial takeaways, we noticed that with the language identification models we use, there are sometimes common mistakes that are made with models. These are results from the Whisper version 1 large model, and it would make common errors that are maybe a little odd if you're familiar with the languages. For instance, confusing English for Welsh, or confusing Spanish, or confusing Galician, which is a language close to Portuguese, for Spanish. There's also significant ambiguity with all of the Balkan languages, in part due to changes in how the metadata is used to describe these languages. So for instance, many of the languages that are either Serbian or Croatian would be listed as Serbo-Croatian in the UNESCO metadata, but now would be listed as their own separate language codes. But if you make a mistake, for instance, your model predicts something as Serbian and it's really Croatian, you may end up with an output of your transcription in Cyrillic, and so that may be quite difficult if the reader can't read Cyrillic. On our diplomatic analysis front, we have found that many of the programs have quite standard structure. So for instance, the first 30 seconds of many educational programs and interviews has a similar format where they introduce the speakers as well as the topic of the recording. So we find this very promising if we can identify a consistent place where these are introduced. It seems like it would aid in the extractive summarization process. You'd identify that, grab it out, and that may be a major benefit in making this description. Similarly, the ends of recordings often have a sign-off, so saying who is speaking and from where. And that's useful for identifying the place of the recording. Next, I'd like to talk about some of the limitations we've found with using these tools in a highly multilingual environment. To motivate this, I'd like to point to Vitorino Veronese, who was the UNESCO General Director from 1958 to 1961. He's an accomplished figure who speaks in French, Italian, Spanish, English, and German. There are about 24 recordings that the archives has of him. What is challenging is that in speaking these 5 languages, he doesn't have necessarily the same proficiency or level of fluency in all of the languages. And so in English, for instance, he may come across as having an accent. This is potentially a challenge for language identification tools, which have been trained on first language speakers of a given language. Or it could be problematic for speaker identification tools that may encode linguistic information in their embedding of that speaker. And so an embedding of them speaking English might look different from that representation of them speaking Spanish or French. So our first experiment to examine this was looking at language ID and how robust language ID models are to second language or L2 speakers of these languages. We used 2 different data sets to examine this. One, a set of European Parliament recordings of second language English speakers, and then we used a subset of our own UNESCO recordings, including L1 speakers who also spoke an L2 language on the recordings. We compared many freely available large language identification models, so the Whisper model from OpenAI, as well as Meta's MMS model, which stands for Massively Multilingual Speech. We benchmarked these models, and what we found was quite interesting. On the L2 English dataset, we found that the MMS model appeared to be actually quite brittle identifying English accented speech. So this model was trained to recognize a huge variety of different languages, but unfortunately, one hypothesis is because many of the languages only included 1 or 2 speakers, it may have made it quite brittle to the accent of a speaker. We find that Whisper version 3, however, is a major improvement on the earlier versions of Whisper and does actually quite admirably at identifying L2 English speech. On looking at our mixture of L1 and L2 languages, we still find that Whisper version 3 is the best performing model, performing 90-something percent accuracy. Next, I'd like to talk about speaker identification and why this may be problematic in a multilingual archive setting. So in speaker processing, usually an embedding, which is sort of like a little snippet of data that's used to represent the speaker, sort of vocal characteristics, that sort of thing, is extracted using at this day and age, a deep learning model. And these embeddings can then be compared to one another using some similarity metric to identify whether or not that speaker is the same speaker or if their voices are similar. The idea being one embedding that's close to another embedding should be from the same speaker, or at least show that they have similar vocal characteristics. There's lots of different ways that you can extract these embeddings, and we ended up using the most modern, or one of the more modern approaches, using a deep ResNet. for the different types of recordings that can, or types of tasks that can occur in speech processing, and apologies, there's a little bit of some formatting issues here. We can look at 3 existing speech processing tasks. So speaker verification, which you may be familiar with even if you don't know it. If you use a device that is like a voice assistant, these devices often will check that the speaker who's making the request of the device is the person privileges to access that account if you want to do something like send an email, make a call, or change a calendar. So if you're trying to use someone else's, say, Google Home Assistant, you ask it to like open up the calendar and it says, go check your voice settings, then that's sort of the check that you didn't pass their speaker verification check. These are sort of an open set classification where the goal is there's an enrolled voice that has been okayed as the verified voice, and you're just concerned with any sample comparing against this okayed voice. So it's primarily used for security, and there's usually some sort of backend classifier to improve performance. Speaker ID is a very similar task, but instead you have a set number of speakers where you're interested in comparing a given audio file to see which of those speakers is speaking on it. This is a closed set task because there's a limit to how many people you're interested in. It can also be used for security or surveillance, and often you can have just a direct classification of the deep model to perform that task. A similar and related tool is speaker diarization, where it's asking the question of, on an audio recording, who is talking at what point in time? So you create sort of a diary entry of who starts off talking, who talks next, and so on and so forth. This uses a clustering approach to figure out who's talking when. So it takes embeddings from different points in the recording and clusters them. The ones that are similar are assumed to be one particular speaker. For our use case, for an archives that has lots of audio recordings, but you may not know who is speaking on any given recording, or you may have scant metadata, which just says this person may be on a recording, but you may not know if there's other recordings they may also be on. We don't have the information to perform speaker identification, where we would need labeled information for all of the speakers. And what we sort of want to do is some sort of like cross-recording aspect of speaker diarization. So this is a task that could potentially evolve out of our existing work as looking at how these speech processing tools can be used in an archival context. But there are some issues, and some of the issues particularly impacting the UNESCO archive is the multilinguality of the archive, as well as the fact that the recordings have a very long history. So not only were the tapes potentially, let's say, if they're from the 1950s, then they could have been sort of like 80 years by the time they were digitized. There may have been some degradation in the tape quality that may have left some fingerprint on it. That would be different from a later recording that might still have more of the recording intact. And similarly, there may be speakers who are speaking across time in this archives, and we have some speakers who show up in early recordings in the 1950s and then later on in the 1970s over a 20-year span. And as people age, their voice changes, and the speaker embedding that would indicate that these are the same speakers may itself sort of start to come out of sync. So these are two major challenges that are sort of faced in addressing this issue. To try and understand that, we looked at how robust these embeddings are, specifically first for multilingual speakers. So what we did is we created a subset of the recordings by narrowing it down as close as we could to try and get a recording that had the majority of just one speaker and whose metadata indicated there was one person speaking on it. And so we did this sort of filtering to get about 75 different speakers over 360 recordings covering 16 different languages. We then used a ResNet model embedding extractor to extract mean embeddings. So take a chunk of audio, take a bunch of extractions from it, and then pool those extractions together, and then compare them so that you're comparing the speaker speaking the same language, and then also compare it to the speaker speaking a different language. So what we found is that indeed there is some major impact on these embeddings when speakers are speaking a different language. So there is a major increase in sort of the divergence between the two embeddings. So if 1.0 is purely similar, like 100% identical, it dropped to about 0.53 similarity score for the different language examples. Similarly, the standard deviation of these examples was greatly increased. And so part of that is due to different languages and different fluencies of the speaker may lead there to be a much wider gap here. So some languages may be closer together, and when speakers are speaking those two similar languages, it may not impact as much. But if they're speaking quite divergent languages, then there may be a much larger impact. So this is sort of the reverse of the language ID situation, where in the language ID example, we found that off-the-shelf tools are quite powerful now. In this case, this may indicate there needs to be more work done to improve the robustness of these speaker representations. So our future steps for the project involve continuing this diplomatics-informed extractive summarization process. So fully labeling a set of recordings so that we can train a model to pull out that relevant part of the transcript. We'd like to look at the quality analysis aspect of both the translation or transcription and translation of these recordings. As there are many different languages, we'd like to cover as many as possible for this task. And finally, continuing our work at looking at the speaker embeddings, we'd like to look at ways where we can make speaker embeddings that are more robust to language differences or the time aspect of the recording, either the speaker aging or potential degradation in the audio film. Mahalo. Thank you very much.
Oh, wait, no.
I'm here.
Thank you for that, Peter. As you know, since we're doing something very similar along the video aspect to it, I'm really intrigued about how far ahead you are. And in the transcript translation analysis part, are you doing that just against the model you're using? Or you did mention some of the commercial off-the-shelf being kind of close, but are you going to run the same recording that you validated transcription and translation through to compare all of them to see does one handle it better than the other? Are they better in Romance languages versus other dialects and things of that nature, so that those of us who want to consume all of your research know which tool to turn to?
Yeah, absolutely. That's a great point. So the performances of these models, both in terms of transcription and translation, are going to vary greatly depending on the language in consideration. So for some languages, Spanish in particular, there's very high accuracies or low word error rates for transcription tools, but that may not be the case for what would be a language that's less represented in online digital media. All of these tools are trained on the data that is available online, and so that has a bias in terms of the performance of those models. So what we would like to do is have a breakdown both by language and over a series of models. Thank you.
I'm very interested. There are a lot of recordings, very large volumes of recordings of things like city council meetings.
Yeah, absolutely.
And these sorts of things. And very often these city council meetings have tens or hundreds of different speakers, people coming up and asking questions and complaining and so forth. And I'm sort of wondering if this technology has any reasonable hope of being able to pull those things out and, for example, identify a speaker that comes to meeting after meeting after meeting and associating that same speaker across multiple meetings. Similarly, there's a problem, we'll call it in forensics and surveillance. So you have surveillance situations where you're listening to people in rooms and you have, who knows how many people in the room talking, and you're surveilling the room over an extended period of time and you're trying to figure out who said what, especially for a legal matter, so you can attribute, things that are said to different individuals who said them, so you can figure out who to prosecute for what. So do you perceive this as having any hope to help out in these problems, and to what extent and how much work would be required to move towards that level of generality?
I think that the situation in sort of a radio archives is quite different from like an open meeting, which may limit the generalizability of some of the outcomes here. But I would say if there's a limit on the number of speakers, like if that number is fairly low, then you're more likely to have success, right? Because you're less likely to run into cases where two people have a similar voice or something like that. For city council meetings, so in the context of like the stuff Adam's working on, where there's video and there are faces alongside speech, that may be a little bit more reasonable in the sense that you can do like a paired face-voice identification, and you don't have to rely on the voice by itself. In a pure audio context, eventually at some point, with enough speakers, just by chance, it may be the case that you'll run into some false positive matches. In our case, we're actually more concerned identifying a specific subset of UNESCO VIPs or UNESCO personalities that we have a list of. And so it's a little bit more tenable in that situation if we can identify a good audio recording, or we have a sense of that number as the cap, and we can sort of ignore other people who might be on the recording, then that's an easier problem, basically. Yeah, thank you.
Thank you very much, Peter. Adam? I don't see Jessica's presentation here.
It wasn't in the folder last night when I downloaded it.
So am I just looking at the wrong thing? It should be 10.
This was literally everything that was in the folder as of 9 o'clock last night.
Right. You introduce Jessica, I'll get my computer.
So we are attempting to locate some hidden bits. And I get to introduce a very dear friend of mine, Dr. Jessica Bushey. She's an assistant professor in the School of Information at San Jose State University in California, where she teaches courses on reference and information services in archives, preservation management in archival repositories. Jessica is the chair of the Reference and Access Working Group with the InterPARES Trust AI. Prior to joining SJSU, she worked with municipal archives, university museums and archives, and international organizations to develop policies and procedures for managing and preserving digital images and audiovisual collections. Recent publications include a participatory archives approach to fostering connectivity, increasing empathy, and building resilience during the COVID-19 pandemic, and AI-generated images as an emergent record format. And apparently I haven't stalled quite long enough. She also holds her PhD from one of the finest archival universities in the world, the University of British Columbia, School of Library, Archives, and Information Studies. And I'll let her start free-forming it while we try and find her presentation.
Could you stop the video up there from this foolishness, please?
I do? Sorry, I didn't mean to scare you all with the screen pictures.
Maybe refresh it or something?
No, this is the folder. She's got it right there. So you can start talking.
Okay.
Start pantomiming.
I'll say thank you. Thank you, Adam, for hosting us, and thank you, my colleagues, for a great 3 days prior to this in our research plenary. So today I am talking about 2 different studies. One of them is in the Research and Access Study Cluster, in which I'm the chair of, and it is focusing on AI and images collections. And mostly what I've been looking at in the last, I guess, year or two is what studies are being done throughout the world, trying to implement AI into the reference and access process, particularly in archives where they are trying to make images collections available for public access. It's the incredibly disappearing presentation. So get ready. You're going to want to move over because we're going to start doing dancing together, possibly, okay? Really?
In case you haven't noticed, we're all family, so we just have fun and just go with it.
Okay, so what I've noticed in the last 2 years is the beginning of these implementations in which archives are starting to try and use AI to help do public access. But what I'm beginning to see is that it's early days in this, and so what is primarily happening is the use of really content indexing using computer vision. And so we're not seeing at this point a complexity or a real sophistication in which perhaps more context-driven information is being sourced by AI software in the images collections that it's being pointed at. And I would venture to say that that's a development that will be occurring in the next year. But at this point, what we're really seeing is more of along the lines of what my colleague Hervoye presented on earlier today, which was AI being used in the portrait gallery of images. Another example that just came online with the Galt Museum and Archives based in Alberta in Canada is an example where a large newspaper morgue of images was found, and they wanted to try and get these images online, but they have absolutely no metadata for these images. They have no archival description, but they have been pressured to get it online. They have low resources, so they have now coupled with a company in Switzerland, and they have started to put all these images up. And so the question that I'm starting to ask around those images archives and AI is really, what is the intent behind making these images available using AI? What is it for users? If so, what are those users' needs? If it's for archivists, at this point, I think it's quite limited, and it's not really meeting the needs of archival description or context metadata, which is really what initial conversations about using AI and applying it to images collections, at least in our research study, RA01, they were really driving at that. How can we make it so that archivists, when they receive an acquisition with 100,000 images, born digital images, for example, how can they use extraction of metadata through automated processes, but also how could they then integrate AI that would assist in that? And then the idea is that out of that pipeline, they would then have all these images with somewhat robust metadata, allowing the public to get at that item level access, which of course we have trouble providing in archival collections that are online, even though often the role and the goal of digitization activities is to give that item level access to images, because we know that's what a lot of users are looking for. So at this point, on my slide, you'll just see that I am giving an example from the Hawaiʻi State Archives of some images that are online. I'm also just looking at, we're quite used to seeing digital image, digitized or in rarer cases, born digital image collections online. And so that's the driving force between, with the RA01 study, is to increase access to these types of collections through AI-generated metadata. But at this stage in this research, I really have been just looking at some of the case studies that we're starting to produce through InterPARES Trust AI, but also looking at some initiatives that are coming out of Europe and North America that we can maybe start to learn from. And we've done an annotated bibliography. I've been working on a literature review, and then of course Adam, who's part of this study, is also doing the video indexer with Microsoft. So the early findings, I've already spoken on this, I think, in the last few minutes while I've been waiting for the slides to come up. So I won't go into too much detail there, but really what's happening is that bottom line is human oversight is still needed. This activity of labeling images and training AI to find certain things in images, I think this is an area that needs a lot of work, and we have seen at this point approaches where almost no archivist participation is occurring in the labeling and seeing what's happening. And then on the other hand, we're seeing some initiatives where historians or digital humanists, experts, data curators are being brought in by the archives and being asked to really create labels that only an expert would know, so that you can target specific users of your archives. And so those are two different approaches, and I'll be reporting on where those are going as this project continues. So, and I mentioned some of these questions already, but really, you know, what is the impact on user satisfaction? How will we know? So I think another phase that will have to happen at some point is, you know, doing tests on, you know, once you've implemented the AI, are you finding that records that were never used before, or images that were never requested, are they now being used, being requested because people can actually find them? Because of course we always have to justify why we are introducing a time-consuming and in many ways probably costly software to archival activities and services. So I think it's important for projects that are starting off now, once they are implemented and actually active, that there is some form of evaluation that's done so that we can determine if this effort is really worth it. Okay, so the main focus of my talk today will be on the creation and use 08 study, and the reason why I'm focusing on it is because I just finished publishing a paper on it. So the systematic literature review that I did, I'll talk about some of the early findings of that, and then this study will continue and I'll talk about some of the next steps. So as I mentioned, this is in a different study area of our project. This is in creation and use. And it is looking at the record-keeping practices of creators using AI to generate images. So initially, we did a literature review, and we were just looking if we could find keywords such as, you know, AI-generated image, synthetic image, and see if we could find any literature in archival journals or records management journals, and we really didn't find any. So we expanded outward, and we discovered that there were discussions in these areas, but they were coming from the areas of journalism and communications, medical diagnostics, and law enforcement. Sorry, just something kind of went, okay, so here we go. I just briefly, of course, many of us are already using generators, AI generators, to create images, either from prompts or textual prompts, or even now you can drag images into the prompt space to then generate more images. And so, you know, these are now available to the public, and because of that, we are seeing the effects of that. These are clips taken from the New York Times primarily, and of course earlier in the keynote speech, Doug mentioned that there's been, you know, Gemini had this issue that came out in the last week about a prompt and what happened. Suffice to say, we are now able to make images that, AI-generated images that look very real, and we have trouble telling if they are from, if they've been manipulated or if they've been created from prompts. It used to be that we could look at the fingers, sometimes the hands would have 6, 7, 8 fingers, or in the background text on a sign would be garbled, or if it was on your t-shirt. But those easy ways for humans to just visually look and verify an image are now no longer very useful. Woo! Wow, that was amazing. Okay. This is really a joy today. Okay. So next slide, although it's, okay. So the rationale for this research is I have always been extremely interested in photographs. I am very aware of lots of researchers who love photographs and images. And so I've always focused on disruptive technologies to photography. And photography itself can always be considered a disruptive technology. And so in the past, I've looked at social media photographs, born digital, and manipulation and believing what you can see has always been a discussion in this area. So to me, it's quite natural that now we have AI-generated images, and we're asking some of the very same questions that we've asked 10 years ago or 20 years ago about things like, how can we tell if they're authentic? How can we tell if they're accurate? Those sort of things. So the rationale behind this research is to actually look at how AI-generated images are created and used. So focusing more on the creation and use side so that when archivists and archives receive these volumes of born digital media, we as archivists can actually already be prepared where to look to understand, where's the metadata, how do we know if it's AI generated, how do we know who the creator is, where's that provenance information in the metadata, and also where's the use information in the metadata, where has this perhaps been published, or can we find out if this has been used in training data, for example. So wanting to know where we can get that information. And so that's what the aim of this study is, really looking at the early creation and use phase so it can inform the later acquisition, descriptive, and preservation phases. So when we did the literature review, we ended up with 61 sources, primarily from journals, newspaper articles, conference papers, etc. We looked at the Library and Information Science Source database, but we also found a lot from the Factiva database. If you're not familiar with that, it's mainly news journalism. So. And that's no surprise. There's been a lot recently in scholarly journals, in journalism, about the hype of AI and the massive amount of articles that we get on a daily basis about AI, especially AI-generated images and now videos. And so I put up the keyword searches we used, and we analyzed the content, and like I said, we really found it fell into 3 disciplines. And then while we were looking through doing content analysis, and there were 3 of us, we started to notice thematic categories where we were taking codes that came out of the content analysis and sort of grouping them under larger umbrella categories. And I'll talk about those thematic categories as well. So overall, the results from the field of medicine were primarily that synthetic images are being used. They're mainly being used to contribute to training, to look at things like, can we create synthetic images of an unhealthy brain or of tumors, for example, and how can we use that to compare and to learn? And so very much a part of medical diagnostics. And of course, in the medical world, whenever they have images, they have their own metadata standards. So they use something called DICOM. And so we started to see a few conversations about possibly could the metadata in DICOM be used to alert that either the training data had been used for that image, or starting to try and get a bit at the provenance and use of those images, and perhaps it could be in the DICOM. And then we also started to see this idea of an actual coalition about AI being created in 2022 around the industry, and looking at some forms of oversight for the use of synthetic images in medical diagnostics. And in the field of law enforcement, understandably familiar to me and probably everyone else is the use of facial recognition technology that is highly discussed in the articles, talking about issues with bias in the training data sets. And then we also saw a lot of articles that were starting to talk about the importance of detecting deep fake images and, of course, deep fake videos. Lastly, in the field of journalism and media communications, we saw some familiar discussions, at least to me, from what I had been hearing my colleagues and speaking in InterPARES Trust AI, and it was this idea about the loss of public trust. Again, how can we believe what we see now that we know what we can do, and we can do it ourselves by having, membership to DALL-E or Midjourney, and we know we can make some pretty amazing images in a matter of a minute or two. So this idea that now we're having, again, this crisis of trust. And again, there were conversations about the detection of fakes, verification of authenticity, establishing provenance, making that provenance persistent over time. And what came out the most, which seemed very useful to me, was this product, which is the C2PA metadata specification, which has come out of the Coalition for Authenticity, which was created by Adobe, but has sort of had buy-in by the New York Times, BBC, CBC, Google now. I mean, all of the large what they would probably call themselves media content disseminators, aggregators, producers, et cetera, have realized that if we no longer believe anything, then why would we be watching the news, or why would we be using their services? And they realize that it's very important to try and make sure that people understand the provenance of the content that they are accessing. And that content in their approach can be images, it can be video, it could be any type of AI-generated work. So it could also be, documents and texts, etc. And of course, the other big topic that came up is the idea of copyright in the age of AI. Who owns the copyright? And the US Copyright Office has already had a preliminary ruling on AI-generated work, saying that if it is 100% AI-generated, it cannot be copyrighted because it's created by a machine. Only if there is interaction and changes made by a human can we start to copyright AI-generated works. And of note, both the Canadian and the US Copyright Offices have had a period where they have now opened up copyright for public discussion and feedback, which we have been involved in. And they've done this because they realize that this is maybe a bit more complex than initially thought out. And there's several aspects to copyright, which I will talk about in a minute. So I just threw this up. It's a beta glimpse, but in the world of images, especially with press images and journalism, the International Press Telecommunications Council has a metadata standard, and it has fields and elements in it for all types of provenance information. Originally, who was the photograph taken by, where, date, where is it being sent to, those sort of things. And so the C2PA specification that I was telling you about, the IPTC has recognized it and is trying to bring aspects of it to standardize it as well, so that every press journalist out there that's taking photographs would have access to those metadata elements. Recently, the Leica camera came out with an automatic metadata profile that can be linked to your images when you take the photograph, and it allows you, I just wanted to add, these are new ones, so you can see it says trained algorithmic media, and then the explanation is The image was created using a model derived from sampled content. They have a composite synthetic. The description is the image is a composite that includes synthetic elements. And then the bottom is algorithmic media. The image was created purely by an algorithm, not based on any sampled training data. For example, an image created by software using a mathematical formula. So at this stage, this is still pretty highly technical, but what I'd like to point out about it is that you can see that these are kind of the major areas of interest right now is, where did this image come from? What's been used to create it? Who are the parties that have been involved in its creation? So I mentioned earlier that through the systematic literature review, we came up with these thematic categories. And so I'm going to discuss them very briefly. There's more in the paper, and it's available online if you want to look at it. But the categories we came up with were authenticity and verifiability, so those things that contributed that, manipulation and misinformation, bias and representation, attribution and intellectual property, transparency and explainability, and then ethical considerations. So authenticity and verifiability, we put under this category approaches and activities that focus on contextual information that contributes to the creation and use of AI-generated images as trustworthy records. And so, as I've mentioned, at this point, we're very interested in the C2PA metadata specification because it's being made available through open source provenance embedding tools. It comes with content credentials, like I said, in Adobe Photoshop. Leica cameras are now carrying it. So we see that this will, and because of the people who are, the industry that are behind it, we see this as probably becoming an adopted standard, and therefore we should understand better how its elements, if we look at them from the perspective Luciana this morning put up onto the screen, the creator guidelines and the preserver guidelines, which were products of earlier InterPARES. So those are very interesting guidelines because they inform us of a prior product of InterPARES, which were called the benchmark and baseline requirements. And so when you look at the benchmark and the baseline requirements, you can actually take what I've done in the past is take metadata and look at the elements and see how they compare and either fulfill those needs and those requirements. So we'll be doing that in our next steps in this research study, is actually taking C2PA and the IPTC standard, looking at them, the elements, comparing them to the benchmark and the baseline requirements, and seeing if they actually do fulfill the archivist's ideas of what is necessary. The next one is manipulation and misinformation. And so we looked at approaches and activities that we found contribute to identifying images that have been intentionally altered or created as fakes. And so what we're thinking of here is, how do we establish trust credentials and definitive statements about the reliability and accuracy of born digital images or AI-generated images? And so either can that come through the metadata, or are we finding that through guidelines or established procedures? So in this early phase right now, we're having trouble finding anyone who says they have guidelines for creating images, but we are expecting those to evolve quite quickly, especially now that there's being so much of a push in the world of journalism and communications for use of the C2PA standard. In the past, those things have come from things like the press and journalism having guidelines for like ethical uses of photo manipulation, or in the law enforcement area, we've found in the past that there would be procedures and standard operating procedures for taking digital images at crime scenes, et cetera, what kind of information you needed to make sure was with those images, et cetera. So I think we're going to see stuff like that come up around AI-generated images as well. Bias and representation, approaches and activities that focus on training data sets or for generative AI. So we're starting to see some emerging policies aimed at the importance of the images and labels used in training tools, and efforts to identify the provenance of that training data to reduce racial and gender bias. So in discussions about facial recognition software, there are some very interesting historical accounts of the databases that were used for facial recognition training, and the biases that were involved in those. And so it's very important that we be aware of what training data goes into the tools that we are then applying to, for example, archival collections of images if we're wanting to make them more accessible to users, like we're wanting to do in the RAO1 study. And then we also need to be aware that there are a lot of photographers who do not want their images being used in training data, and there are several cases that are starting to come out, lawsuits where not only photographers, but in some cases actual newspapers and news services, where they are finding images that are copyrighted that are now being part of they were scraped and used in the training data for some of these large AI generative technologies. So in attribution and intellectual property, these are approaches and activities that are specific to the rights and responsibility of AI-generated images. And I've spoken about this already in this presentation, but just to be aware that it's really these sort of 4 areas. The use of copyright-protected works in the development of the AI system is something that we need to be thinking about. Potential for AI-generated outputs to infringe existing copyright-protected works, and the role of AI systems in generating content and approaches to accurately attributing works and determining the copyright protection, and then lastly, lack of practical enforcement remedies for rights holders. So at this point, there have been a few cases that have been talked about, but everyone's very aware that there are going to be many more. So that's something that we are going to continue doing research on and looking into, because it's moving quite quickly. Last is ethical considerations, concerns and approaches specific to privacy requirements. And in this area, we are looking at issues raised regarding personal identifying information, so PII, in both the medical, the DICOM metadata standard, and in C2PA metadata. So in that metadata linked to images that could end up being included in training data, we question what about the metadata that might identify who the person was that maybe this medical image is of, or even just who the people are of an image that someone's taken that then is used in the training data, which then becomes part of that AI tool that someone else is using for a different purpose. So it's just something that right now we're not very clear on what the rules are around that and how it could affect the end user. So this is the research questions that came out. So part of the systematic literature review, the goal of it was to actually identify our research questions. And so we are looking at how are individuals and organizations using AI-generated images, what AI tools and technologies are being used. So this is both the commercial off-the-shelf and what bespoke AI is being created. What actions are being taken by individuals and organizations to identify AI-generated content, And lastly, what standards and or policies are guiding procedures for creating, using, and preserving AI-generated images? And it's very early days, but I do know, personally, I know several photojournalists who have, due to the tools that they're using, like Adobe software and Leica cameras, are now able to be capturing this metadata. They are using these tools. All of us have probably seen on Instagram and even on X that you'll see an image and you'll be totally captivated by it, and then you'll look in the corner and it'll say like AI generated image or AI generated content or AI generated work. Depending on where you're looking at it, sometimes it's called a synthetic image. So we're starting to see these images being used, being circulated, and we're seeing also measures taken to let the viewer know what they're looking at. But the question is, you know, at this point, is that required? Is it, you know, who is it up to make sure that they're disclosing this information? And of course, we're very aware of the massive amount of disinformation and the appeal of disinformation or misinformation out there. Hence some of the images I showed earlier on with the Pope wearing Balenciaga, or some of the other things that you know that have circulated online. And let's see, there's just, the next steps for us are, like I said, analysis of the C2PA specification using iTrust creator and preserver guidelines, and of course the benchmark and baseline requirements that are behind that. Analysis of evolving intellectual property rights for AI-generated images. Analysis of emerging industry-specific policies and procedures for AI-generated images, if we can find them. Collaboration and or participation in industry-led guidelines and best practices. So trying to get an archivist, probably myself, somewhat involved with CAI. At this point, there doesn't seem to be any archivists that have been involved in that specification, C2PA being created, or even in some of the conversations that are happening by the CAI. And then we will also be looking at creating a survey of content creators that are using AI-generated images, and then probably doing some one-on-one interviews, because I don't expect that to be a very large group in the survey, to be able to know a little bit more about what some of their concerns are. And that is it for me. You can use this email if you want to contact me and ask me anything more, or if you actually know some people who are using AI-generated images that you think would be good for us to survey or interview, that would be great. And I see Fred has a question. Awesome.
Yeah, can you comment on what we can reasonably do to prevent, I'll call it the pollution of archives with false, misleading information? And then also talk about the potential role of archives in countering disinformation campaigns.
Okay, well, I know this is actually a really favorite topic of Luciana's. What I will say, so I'm just going to end up paraphrasing her, and that's never good, because I don't have the accent. So what I would say is that, you know, I see the role of the archivist in that we need to know what we are receiving, and we do our best when we acquire or have transferred to the archives the materials to know, you know, who created them, what are the copyright restrictions around them, who's in those images, you know, what's the provenance, and always to make sure we have as much information as we possibly can, because that means then we can make them available, and through our archival arrangement and description practices, we, you know, preserve that authenticity of the contextual and the content information. Now, if people are creating AI-generated images as part of their routine procedures at work, then to me there's nothing false about those. I want that we know they are AI-generated images, we know how they created and used them when they were in their active phase, and then we make sure that that information is available to users of the archive so that when they're looking at those collections, they know that they were AI-generated images. Now, to me, those are not false because they were intended to be AI generated and that's how they were used. Now, the different case of being given images and then false information about what they were or how they were used, that's a totally different situation. And the challenge that I think can happen is if we don't know that they're AI-generated images and a researcher believes that they, that they weren't, but they are, and then we don't have the right information contextually to tell that researcher what they're looking at, what the creation and use was originally of those materials. And that's why I have always felt that metadata with images, including social media images, when it's stripped away from them, we lose the original context of how they were used by their creators, how they were received by people, and how they functioned in the time that they were active. And that's the real risk, is always with images that they get reduced to their content, and researchers come in and just want to use them as illustrations to whatever claim that they're putting forth. That's a disservice to images as a means of communication as records. And I think that my hope is that if we could actually make sure that the metadata is persistent, that archivists understand how to extract that metadata and are prepared to know what type of metadata should be there from those systems and those devices and those platforms. That's my hope, because then at least the archivist has as much information as possible that they can preserve and make evident to the researchers. But I think it's going to be difficult. I know it's difficult for social media images. The minute they're downloaded, oftentimes those communications of people commenting and liking, which is part of their usage, gets stripped away from them. We lose that context. An image that's an Instagram that's been liked 800 times and has 2,000 comments, without those comments, and when you download it, it changes. It just becomes that image. It doesn't have that dynamic interaction around it. And I worry that AI-generated images that we'll lose, we won't have that metadata that talks about the way that they were used and how they were generated. And I would even like to see that the tools that created them, like that we would know that it was OpenAI or it was DALL-E or it was Midjourney version 4.5. I think that would be really useful as well, just the same way that images often will have the device, the iPhone, what version operating system it was embedded into their technical metadata. So I think that would be great to have. But yeah, it's a great question.
You totally just answered my question too. You're so good about that. So thank you.
Sure, Proscovia, and I'll make my answer in one sentence.
Wait, no, Proscovia. No.
I'll repeat it.
You need to come to the microphone. If you're going to ask a question, it has to be at the microphone.
Will you come and load Basma's presentation while Proscovia asks her question, please?
Thank you, Jessica, for your wonderful presentation. This is a very brief question, and I'm wondering, so you've done some literature review. You made reference to the, synthetic images that are being used within medicine. Have you also come across about policies sort of guiding the usage of these images, apropos the, when it comes to the question that Fred has just asked of polluting the archives? Are there any policies, for example, within medicine that guides, the use of the synthetic images from the actual images? Thank you.
I haven't yet, but I have just been introduced to a data scientist who's been doing a lot of work with synthetic images in medical diagnostics, and so I'm hoping to reach out to them. But if anyone knows of any researchers doing that, that is an area that I would love to know more about that we don't have a lot of contact with. Thank you.
Thank you, Jessica. Okay, Dr. Basma Mahklouf. Oh, yes, okay. Dr. Basma Mahklouf Shabou is a professor and head of the archival science field at the University of Applied Sciences and Arts, Western Switzerland in Geneva School of Business Administration, where she is also leading the Department of Information Sciences. She holds a PhD from the University of Montreal, as well as a postgraduate degree in records management and a bachelor's degree in social studies. Basma developed the National Program of Public Records Management of the National Archives of Tunisia. She has contributed to the teaching, design, and revision of various archival programs in different countries, University of Montreal, the Sorbonne University, University of Manouba, and others. Her research focuses on archival appraisal, defining and measuring data quality, information governance, information risk assessment, and research data. She co-leads the DLCM2 project, has presided over the OLOS Association since its creation in 2021, and is active in various expert groups. She has created the archival laboratory Archilab in Geneva.
And we're still waiting for that.
I have it on my...
Here we are. So thank you for waiting this time. And I will start by saying thank you to invite me today to talk about our research on maturity assessment for appraisal in the AI age. And this is really an honor to be here and to share with you what we have done in this field. So first I will try to bring up the basic elements for the context of this project, of course the objectives, and I will share with you the important elements of our methodology to finish with some elementary and preliminary results on what we have done till now. It will be basically what I will present briefly the model and the dimensions that compose this model, and the simulator that we have designed for that, and a few words on the case studies that are ready now to be shared. So by model, I mean the framework, basically, of our ideas on how we can manage the readiness of appraisal function to welcome, to also prepare the use and the integration of AI facilities. So the context briefly is InterPARES project, of course. Nothing to add for what was said this morning, and maybe in the room I'm not able to see someone who is not aware about this wonderful project, this legendary project, I should say. So completely in alignment to these objectives, I mean the objectives of InterPARES Trust AI, including the aim of exploring AI technologies, their also capacity to enhance and to embed, to reinforce our capacity as a records manager or archivist, and help managing also all the challenging aspects related to risks. Our awareness about maintaining principles is also very important, and that will be also one of the interests of our projects related to appraisal research. The work on case studies is very important to bring different sites and different ways to see the same problem. And as you can see, also, one of those problems, the technology and the adaptability of the technology to each context. Each government has a set of requirements, a specific framework, including juridical, regulatory, also aspects. Another aspect related to the case studies and their capacity to bring also what is mattering with the terminology. So in the same language, you will see also that there is something to fix. I'm talking, for example, what I have in mind, the French language, which is very complicated. Once applied or used, technically, we can really get a lot of trouble, difficulties if we start a project related to the digitization, for example, with many professions, including IT guys. We will suffer first to fix the problem of terminology. What we mean by archives, what we mean by data, what we mean by information. And you can imagine the list of questions that we can have to fix. Related to regarding to the appraisal now, I'd like just to remind this briefly what is meant by appraisal. The use of appraisal in this project includes many aspects, includes the process and the tools and all we can do to make sure that we are choosing the right series of documents and data to document properly the business activities and all we want to report for the coming generation on an entity. That means that appraisal will also consist to determine which record need to be created and captured, as well as how and how long the record need to be kept. So it's not only the simple question to say what we keep, what to not keep. It's also including the responsibilities in terms of those decisions, the question of ownership of data, the question also of the way and the environment of maintaining the data sets and archives for the coming generations. Interesting to see that creation is also mentioned in this ISO definition, because classically we will think about the last part of the life cycle of documents when we talk classically about archives appraisal. So this is the frame, this is the definition we are using for the project, and our objective in this specific study, which is dealing with the maturity assessment of appraisal in the AI age, which will be based on 2 years. We started at March 2023, and we aim to identify the archival, technological, cultural, and strategical barriers and facilitators to effectively apply NI tool for appraisal. The idea is to enable and better our capacity to perform appraisal in the context of different institutions. Including public entities, international organizations, private also entities. So this study will develop a model to assess the appraisal readiness for AI. For that, we want to understand better the consistency and the predictability of appraisal decisions. We want also to see what are the requirements and also the pre-requirement things to prepare to be able to integrate an AI in a given appraisal practices. The maturity of data and archives processing for automation or for smartification of this appraisal. What is the situation first in these entities, these institutions, to be able to see what is needed, what actions are possible, what are the processes that we want to perform to reach this objective. The objective to integrate an AI tool. Our objective is also to provide some practical tools for institutions. For that, we want to target and to express and to define precisely what are the complementary actions for improving appraisal practices to integrate artificial intelligence. This idea started first with the real work, a consultancy that are initiated with our partner in Switzerland, based on a conceptual model that I developed with the State Archives of Wallis. And it was really very interesting to see how things may be approached in a concrete environment. So the methodology is basically qualitative and is based on applied research methods. Our work started first classically by systematic literature, and what we are doing now is the collection data by focus group and Likert scale survey. Those two collection method will help us constructing case studies. So concretely, we started by a scientific consultation, some exchange discussions, but also documented discussions with research head in UK National Archives, and also some other colleagues from University of Geneva with AI specialists. The second step is, in parallel, we are also advancing this consultation with the professionals, with colleagues from National Archives of Brazil, Federal Archives of Brazil, the National Archives, Library and National Archives of UAE, National Archives of Luxembourg, and also the UK National Archives. From European side, as you can see, we have the City Council of Girona, les Archives cantonales vaudoises in Switzerland, UK and Luxembourg. But what we wanted also is to try to see what is happening outside of European context. I'd like now to share with you briefly what is the model. I mean, the framework, what we have advanced till now, is principally these 6 dimensions: principles, vision, and strategic frame, the dimension of compliance with different level of compliance, the methodology and related processes, all we can imagine as operational aspects to perform the appraisal, and of course the operational aspect related to different tools classic ones and automated one or semi-automated one. When we talk about appraisal, we cannot avoid the discussion on criteria and metrics. The things that we are using, we can say consideration, criteria, and all you can imagine, but regardless the detail or the level of accuracy of this consideration, this is really very helpful to maintain the systematic aspect or character of the appraisal, but also to help professionals to argue and to explain why they are deciding to maintain, to long-term preserve such a document and decide to eliminate others. But concretely, these six dimensions are detailed in sub-dimensions. For principle, we are also focusing on accessibility, the idea of assessing the values on the basis of life cycle, the idea of a classic and traditional principle, like the respect of fond, the multi-dimensionality of the assessment of document, the centrality of the value, and so on. So we worked on principles also to see how to try to maintain the activity of appraisal by integrating many considerations that we have, such as inclusivity, also the sustainability in two senses. The sustainability, for example, here is discussed in two senses. The sense, the ecological sense, and also the archival sense. And as you can see, the 6 dimensions are developed in detailed way to help assessing also for each of one element here, the development and the maturity of each one and its capacity to integrate the AI tools. So we used the maturity assessment tools and method to apply our model. So we considered 5 levels of progression for each element. And concretely, we created a simulator. It's an Excel document, open for testing if you want to test and to see what is behind it. And it presents all the 6 dimensions, but in a detailed way, including some brief descriptions and also another additional aspects to check. For example, if I am in national archives or in private archives or wherever, where look the context, we can try to see if I am advanced or not applying the principle of accessibility. How open the funds are in our context. Am I applying the rules of life cycle management? Am I using the principle or some considerations regarding the sustainability? For each, we will try to give some indicators. And for all these, for each line here, we will consider and we will be able to situate our reality in that scale. Of course, this is the aggregation of the model. It's not detailed. In the detailed version, we have for each level what is the requirement, how we can identify our reality in that scales. For the level 1, we have all the specification related to level 1. And the worst level and of course, till the the ideal situation, like let's say the level 5. And concretely, we will be able to so identify the level that we are, that seems to be our level, and some justification will be added in the line of analysis, and we will add sources and all the information that led us to specify our judgment. The last element, which is recommendation, will be the improvement to do. In that point, we will see which kind of AI may help us to do better. And which is interesting is also to see and to provide to the institution the possibility to better their practices in each point. That doesn't mean that we will offer another column to see a list of tools for each line here, to see and to tell them that artificial intelligence may help them to transform their reality. But we can imagine something that can be very useful for some aspects. I took the example of principles, but the dimensions here are related also to compliance, to methodology, including the appraisal process, reappraisal process, the disposal process, the identification of information assets, the identification of vital records, the identification of content, and so on. So this is just the logic way and the method that we are considering in this work. So, what we have also advanced till this point is also the testing of the model. Thanks to the consultation that we advanced with some colleagues from UK, from Brazil, from Mexico, from also from Switzerland, we are able also to adjust, for example, the terminology. We are also able to see how to manage the details and add some clarification on each description of the model at the maturity model. And also we are really lucky to have the help of our team to get a Spanish and Portuguese version of the model. The model is translated to those two additional languages added to French and English. So what we finished till now is the study, 3 case studies. So the case study of Federal Archives of Brazil in Portuguese. The work done by a master student from Sorbonne University, which is Amna Al-Ali. She worked on testing the model in the context of Library and National Archives of UAE, and the French case, it's Swiss case that we have finished also in French with State Archives of Valais. So what we want to do now is to work on some publications to share this first work done on this model, and to work, of course, with our colleagues from University of Geneva, Lamia Friha, who is our specialist, AI specialist, who will help us to match and see for what we can add, we can imagine some helpful functionalities from existing AI. So I think I'm done with this. So please, if you have a question, don't hesitate. And this is my email. If you have some questions, or if you are interested to know more about this model, please let me know. This can be open also for consultation for all you want to do with.
Thank you very much, Basma. Are there any questions for Basma? Yes, Proscovia.
Thank you so much, Basma, for your presentation and good work. I'm just going to make a provocative reflection, and this is, we are in the age of big data, right? And of course, we have the artificial intelligence people in the room, so they may want to guide us. There has been a school of thought that has questioned why we as archivists, where we are so obsessed with appraisal. People are asking, do we need appraisal in the age of big data? And I would like you to, just convince me if we still have to go that way.
Thank you very much for this wonderful question. Well, that's very interesting. And at the beginning, when we started discussing this project, I used, this is really very important to say, I used archives and data. Okay, just for prepare the level of big data. And now we are just thinking about how to marry appraisal stuff, all what we have to do with the appraisal, starting from the capture, the reception of stuff and the materials, and the exploration, discovery of the contents, till the decision and the application of the decision. Just, we need to make sure that we are able or not, and where we can do something. After, this is interesting to consider, to go far and more in details. I will add to that another complexity. The contents are very different. When we do appraisal on photo, it's not like do it on text content. And as you can know, archival series are not simple to assess and to appraise, because they are all the time hybrid. So they are paper and digital. And when we are done with this problem, we will face another problem, which is the diversity of format, not only the quantity. So the complexity have many directions. So yeah, our question is basic, and more than, you know what, when we started discussing this, people who are holding, in majority of cases, holding papers, they are asking us how to use AI. Well, some jumps to do, or we cannot do anything if we don't have digital content. So cannot jump from paper to AI. That's not possible. So big data is another reality, and definitely I will keep it in mind. This is promise.
Okay, thank you, Basma. Our last speaker of the day, last but not least, is Moises Rockembach. Dr. Moises Rockembach is a professor in the Faculty of Arts and Humanities at the University of Coimbra in Portugal, where he teaches information science and researches the intersections between archival literacy and artificial intelligence literacy within the scope of InterPARES Trust AI. His research focus includes how records managers and archivists can acquire and enhance AI competencies, aiming for an effective integration of these technologies in the field of records and documents management. Welcome, Moises.
Thank you, Corinne, for the presentation.
So, last but not least, we're talking about AI literacy. I think.
Killed it.
I didn't touch.
It's also cold and wants to go home.
Perfect. Okay, thank you. So we're gonna talk about AI literacy for archivists. I think it's a good topic to finish this day, because what I'm gonna talk address many of the presentations today. So just get something that Basma just said about the digital literacy, that is a pre-AI literacy. We can understand like that. And this is, okay. So if you, yeah, just a bit delay. So this is our agenda for today. A little introduction about the research, some research findings, and how can we develop a cross-archival AI literacy. So I would like to start with this comic, just to break the ice. So we are living this now. It's pretty funny that we are using AI to read the papers, to write the papers, to review all the papers, and then to access all the science.
Don't tell my students that.
Yeah, it's not to use, it's just to know. But it's interesting that we are using AI in this sense, and this could be applied also for archive and records, the way we generate, the way we preserve, and we apply all the functions. So we need to think about that, not just AI as a tool, but also as part of the team. So that means how we interact with AI. Because now we are thinking about AI systems, AI as a tool, but AI, in a way, can be transformed as an element, as an assistant, a really assistant of our work, and there are implications on that. So this is just an introduction just to show how we start the research. So we are talking about skills, competencies, and record management and archives that are important as ever in a digital environment. And now we're talking with about AI literacy. That means understand how these tools work, and how can we implement in your environment. That means we have actually a lot of another skills here to add, and just let me give a brief about the research. So it's part of InterPARES Trust AI. Is located in an education cluster, among other studies that are working specifically with teachable, explainable AI, and now a recent study approved that will work with market analysis in competencies and skills. Our methodology is we use literature review, documentary research, because there are many guidelines and legislation about AI published recently. And we also applied a survey with around 150 answers. We are going to show some of these answers today. And we analyze that with a content analysis and a categorization. So some of our research finds. This is an ongoing project, so means we still receive feedback from this survey, the categorization. So we're gonna finish in 2026 with the end of InterPARES phase as well. So one of the things that you need to understand here, there are levels of literacy, and that means we don't need, or an archivist or a record manager, no need to be an expert in AI. That can sound as a common sense, but if we don't structure in this way how to acquire competence, so it's easy to misunderstand this part. We have here some examples about what is a basic understanding in record management and archival science and in artificial intelligence. So we start with principles and concepts in AI, but when we go through through application of AI tools or implement AI policies in organization, we need at least intermediate understanding, because there are some implications in how these AI tools interact and affect the records in our archives. And of course, this also means that we always work with the concept of the interdisciplinary teams. But it's necessary to have similar understanding about some concepts, some practices and theories related to AI, I mean, in the side of archivists and record management. So the organizations and also in the literature review, they call this upskilling. That means improvement of the competences. So many professionals that already had their masters or PhDs, they need to take or retake some of these subjects. That is, it's always updating. So about the literature review, we have many findings. I just bring some here that is our background as well. So the application of AI in various areas is something that is growing fast, and in record management and archives is not different. However, there are still many misunderstandings about the use of AI and AI itself. These misunderstandings tend to decrease with use and increase AI literacy, also with critical thinking about AI in various fields of activity. And the importance to approach the data lifecycle, acquisition, cleaning, modeling, implementation, optimization, analysis, visualization, evaluation, sharing, erasing, and archiving. This is part of map. We start this map in the beginning of the research, and we are updating this map about misunderstandings about AI. So, for example, the idea, one of the ideas that was updated, for example, are the barriers related to adoption of AI. So we're talking, just get Adam mentioned here in his speech today, the use of low code or no code, or use of AI-ready softwares, and then many of the use case that was mentioned is AI-ready softwares or shared infrastructures. So it's what happened now in many countries in European Union as well. We're talking about shared infrastructures to control how to use the AI in the data. And some of these misunderstandings are related also to, so for example, misconceptions about what is spread in the news, in social media, in sci-fi. Although these, some of these misconceptions now are, it's not so bad as it was some years ago, because we are using many softwares as ChatGPT and image generation, so we are more aware about what is AI, what we can do. This is an interesting output, is results of the survey we apply. So we have around 150 answers from professionals, practitioners. And we categorize in 5 classes. And these are the 5 reasons not to adopt or not to adopt yet AI solution in archives. And the first one, lack of knowledge or competence, is what we address in this presentation now. The second is the digitization, or the organizations are in the process of digitization and they don't have enough digital documents to process to use AI tools, so they don't see documents they can use in these platforms. The third, lack of reliable technologies, this was mentioned for many in many answers, and these we can relate it also to this phenomenon of hallucination. So if AI start to invent results based in the database, but not in the documents, in reliable source, we can have a big problem. And so the lack of reliable technologies was one of the this is not in order, okay? So it's one of the most mentioned answers. Fourth, not integrated into management systems, because AI is seen as something that must be into the internal systems. And 5, lack of economic and human resources. So this is not just related to AI. You can see in many cases, but here especially was mentioned this part. So how can we develop cross-archival AI literacy? We have here also some categories that was based in the literature review, the documentary research, and the answers from the participants. Many of these categories are related to some of the projects presented today. And this, as I said, is an ongoing project, so we still receive inputs and feedbacks to have a final framework. But this is a basis to make the framework related to AI and archival literacy. So one, to start, are concepts and theories. So general foundation, ideas and theories in AI, record management, and archives. And I mentioned here, I put this news from BBC in 2023. Authentic was the word of the year in the Webster dictionary. And then I remember, I didn't put in the presentation, but in the Cambridge dictionary, it was hallucination. So all all related to AI, but this is specific, I think, is in your field, so it's interesting to see the value that people are giving for that. So I won't go, I won't dig into these topics. I just you mentioned here to show our draft framework. So the second categorization are record and archives. So data literacy, understand and working with data, recognizing patterns, and interpreting results. That's important also to not to just to understand, but to think how can we use data to fuel this platform, the AI platforms. Datafication and digital transformation, that is different because then we are talking about datafication is the process to transform in data, so documents in data, and digital transformation as well, so involved also the digitization process. So the process of turning many aspects of society into data-driven ones. AI integrated record management literacy. So record management principles in an AI-driven environment. Enhanced archival science literacy, integration of AI within the domain of archiving functions. So the idea here is to cross the literacy. They are not seen as different disciplines, but integrated. So where we integrate them? So provenance and Paradata, the previous presentation from Patricia Franks was about Paradata, and we see how important it is to document the AI tools, AI policies, how it works in the organization. So track the origin and context of data used in AI. Then we enter in the computing category. And we have machine learning, and then we work with these concepts of supervising, semi-supervising, and unsupervising machine learning. Computer vision, AI applications that involves visual processing and interpretation. Generative AI, and this is pretty recent, so we start to talk about that in November 2022, because it was when ChatGPT was launched, and now it's part of our daily routine. Also AI applications in natural language process and content generation. Algorithms, implementation of algorithms in contextual analysis. So this was already important in the past. It was always important how algorithms works, because it's a way to systematize many workflows and information flows. So now it's more important than ever. Then about ethics, we have these 5 subcategories. So bias and diversity, address biases in AI, promote diversity. Accountability and ethics, ensuring AI systems are accountable and align with ethical standards. Data protection and sensitivity here is connected also to some laws like general data protection. Ensure the security and appropriate handling of sensitive data. And about the sensitive data was one of the answers also in the survey, one of the concerns, because some archives, some institutions, they don't want to put their data in OpenAI, or they want to keep the data. They need to keep the data with them, so they need to find also new solutions for that. Transparency and explainability. making AI operations understandable to the public. Then legal concerns, because we have the ethical approach, but we have also the legal approaches are not always the same. So regulations and legalities surround the AI, such as the AI Act, for example. Then we have the user-centric categories. We have these and just one more. So the subcategory problem solving with AI, using AI to address complex issues and find solutions. We connect these also with the critical thinking, how we can approach problems in the organizations. AI design interaction, designing AI systems that are teachable and user-centric. And testing iteration, that are methods for evaluating and refining AI systems. And in the end, we have the sixth class, that is organization. So 2 subclasses: AI adoption and governance, strategies for adopting AI and overseeing its use. And finally, collaboration communication, enhancing collaboration across disciplines and effective communication about AI. So with all these competencies, we have this draft is a framework, archives, records, in AI literacy framework, are divided into the topics I just show. So are 6 big categories. And then there's a reason also in the order. So we can read from top to bottom and from left to the right, because it involves also some complex things. So when we are in the end, for example, in the beginning we are working with concepts and theories, and then the data literacy, that is also the data structure, provenance and paradata, that are also part of the essential things related to archives. And then we go into the ethics approach, and that in the end are the organization approach that depends also from another teams and is more top level. To conclude, that was the mentioned example about how the things can go wrong also, but how can we correct, how can we deal with that? That is the most important, how we can deal with that. So this was the case mentioned in Gemini, that's the Google AI, that happens this week, yeah. And so the prompt, it was generating an image of a 1943 German soldier, and then the answer was sure, here is an image of a 1943 German soldier, and then gives 4 examples, and we can see that it was not good, yeah, because it's historically wrong, and it was apply the diversity in a wrong way, and that is a problem to address. And how can we address that? So to study and to check the provenance and paradata. So how this model make this? So that is in the generative AI competence. So the bias diversity, how the model works with that. In AI adoption and governance, just to give an example how we could address this case, but the thing is, in this case, is pretty clear the problem, it's pretty clear that is wrong, but in many other cases, you'll not be. So you're gonna be in some details. And then people I show in the first cartoon, many people just copy and paste. That can be a big problem. If they just copy and paste from AI tools, as they did in the past with Google, for example. And thanks for the team. That's all the team involved, our coordinations, our funding agency, and a special thanks to our host, Adam Jensen. Thank you.
Any questions for Moises? Okay, I think we are done for today. It's been a very, very instructive day. Lots of great ideas, great presentations. So thank you again to our interpreters. Thank you to Adam for hosting, and the State Archives of Hawaii and this building for giving us the space. So please join me in a general thank you. Okay.
And I also have a few specific recognitions that I want to do. First, to Senator Angus McKelvey for generously sponsoring our use of the auditorium in the state capitol. And to Dr. Andrew Wertheimer from the University of Hawaii. He is the one who stuck through the entire day, so he gets the Polar Bear Award. To the students from the Society of American Archivists student chapter at UH Manoa for all of their help in organizing this. I would also like to at least recognize the Association of Hawaii Archivists and the Association of Records Managers and Administrators Hawaii chapter for also extending the invitation to all of their members. The help me make sure I get this right, Disability and Communications Access Board for contracting to bring the interpreters in and opening my eyes to the importance of ensuring that our future events also have American Sign Language interpreters. And lastly, to Alelo for their amazing job doing the streaming. So thank you all. And my archives, Ohana, I love you all. I am so glad that you were here. I was so proud to share you with everybody. Thank you for taking the time, and let's go have dinner. Aloha.